This is the solution to example 4 from notes P.5. In this example, we're going to simplify a complex fraction. A complex fraction is one where there are fractions in the numerator and possibly also the denominator. So in method 1, what we're going to do is we're going to first focus on the numerator and then focus on the denominator. So we're going to simplify uh, the numerator separately and the denominator separately. So here I'm going to rewrite the complex fraction. So we have 5y minus 6 over 2y plus 1. That's the numerator. And the denominator is 5 over y plus 4. And we're going to focus on the numerator. So we want to find a common denominator for the numerator. So the LCD for the numerator is going to be y times 2y plus 1. So we're going to multiply each of the fractions in the numerator by a funny form of 1, so we get that common denominator. So the fraction 5 over y, we're going to multiply by the missing factor, which is 2y plus 1 over 2y plus 1. And the fraction 6 over 2y plus 1, what's missing from the denominator of the second fraction is y, so we're going to multiply that fraction by y over y. Then for the denominator, we're also going to get a common denominator. And so the least common denominator of the denominator is just y, right? Because we can think of 4 as 4 over 1. So the first fraction, 5 over y, already has the denominator we want. The second fraction, 4 over 1, we're going to have to multiply that by y over y. Let's go back to the numerator, and we're going to start the simplification process. So we are going to distribute 5 to both the 2y and the 1. So we're going to get 10y plus 5. That's over y times 2y plus 1 minus the second fraction becomes 6y over y times 2y plus 1. The denominator now is 5 over y plus 4y over y. Let's focus on the numerator again. So now we have a common denominator in the numerator, so we're focusing on this part. So we're going to have 10y plus 5 minus 6y. So I'll write that out, 10y plus 5 minus 6y over y times 2y plus 1. And in the denominator, we have 5 plus 4y. So that's going to become, I'm going to write it as 4y plus 5 over y. Let's combine like terms in the numerator. So we have 10y plus 5 minus 6y, which is going to give us 4y, make it look like a 4y plus 5 over y times 2y plus 1. That's the numerator. And the denominator is 4y plus 5 over y. Now we have we're dividing two fractions, so in order to simplify that, we flip the denominator and multiply. So the numerator is 4y plus 5 over y times 2y plus 1. Flipping the denominator and multiplying, we get times y over 4y plus 5. And now we can simplify. We can cancel out common factors between the numerator and the denominator. So the 4y plus 5 cancels out, and the y's cancel out. That leaves us 1 over 2y plus 1. But as soon as we cancel out these factors, we need to remember to list values that make those factors 0. So in order to do that, let's find out what those values are. So we canceled out 4y plus 5. So we want to know what values make that 0. So 4y plus 5 is not equal to 0. That means 4y plus 5 4y is not equal to negative 5, subtracting 5 from both sides. Dividing both sides by 4 would be y is not equal to negative 5/4. So I'm going to list that up here. And then our other factor that we canceled out was a y, so we say y is not equal to 0. This is our simplified expression, 1 over 2y plus 1, where y is not equal to negative 5/4 or 0. But we're also asked to state the domain. Okay, so for the domain, we need to list any value that was excluded from the original expression. So let me get the right pen. Okay, so for the domain any value that made the original expression undefined. In this case, we have negative 5/4 and 0, which came from the factors of 4y plus 5 and y. So we're going to say it's all real numbers except y is not equal to negative 5/4 and 0. But we also have a third factor. And that third factor is this 2y plus 1. So we also have to figure out what values make 2y plus 1 equal to 0. So we'll solve this little equation here. 2y plus 1 is not equal to 0. So we'll have 2y is not equal to negative 1. Dividing both sides by 2, we'll get y is not equal to negative 1/2. And I'm going to list those. So the domain is all real numbers except y is not equal to negative 5/4, negative 1/2, or 0.